What's up guys, welcome to another Laravel Octane video. In this video, we'll try to explore what is Laravel Octane, how it works, its internals, its CLI, and at the end we'll do some benchmarking as well. Without further ado, let's get right into it. So first of all, what is Laravel Octane? It supercharges your application by, it's essentially a Laravel package which supercharges your application by using high powered application server, that is Swoole and Roadrunner. It's a very intelligent wrapper around Swoole and Roadrunner. It abstract away the implementation and complexity of Swoole and Roadrunner and let us focus solely on the development. And moving on, so Laravel Octane is the brainchild of Laravel team, first party package. Since it's a first party package, we'll get support from Laravel team, which is amazingly talented and awesome in itself. And I just want to say, like, this is not the first package or wrapper around Swoole. There have been another package, and this is the one. So it has been here around like since a long time, at least around 2 to 3 years ago. But I haven't tested it myself. But I have seen some reviews about it, and this is pretty awesome. People have been like using it like since very long, and it has been proven to be very amazing. But now with Laravel Octane, we actually are getting the first party support from Laravel team, and I cannot tell you how amazing is this because Taylor and his team themselves will be working on it, and we'll get our issues resolved very quickly, and we'll also get Octane support on the Forge as well. So yeah, it's pretty amazing. So now, like, without actually before going forward into more of Laravel Octane, I just want to show you how much awesome it is, and how much your Laravel app become awesome with Octane. So let's do a quick benchmarking. Let me create a fresh Laravel app. Octane app new. Let me quickly install Laravel Octane. Okay, so Octane is installed. Let me actually check this application in the browser, see everything is working fine. Okay, so this is the application. So I'm using Nginx here. I'm using Valley, which is using Nginx and PHP 8. And this is also one of the prerequisite for this Laravel Octane. Now we have this on running on Nginx. Now let me start on Octane server as well. So to do this, we can use Octane server. And for underlying implementation, I'll be using Swoole. So let's go ahead. So now we have two application running on Nginx and also application running on Octane. Let's go ahead and benchmark it. So I'll be using Worker to benchmark this. You can actually install it on your machine. So for the Worker, let's check the performance of Nginx with Laravel and Laravel with Nginx. So I'll be using this URL. So we'll keeping 100 connections alive, and we'll be using 4 threads. So it's a 10-second test. So this test will tell us how many requests per second it can serve. So this is a pretty simple app. So there is nothing fancy about it. It's just a home page. It's a very static app. And you can see like 188 requests per second, which is pretty amazing. But now let's go ahead and test the Octane performance with the same Laravel app. And so now you can see like it took 10 seconds, but you can see the performance increase in this application. 851 requests per second. Here it was just 188, around 200 requests per second you can say, and here we can say around 150. So it's at least around 350% increase. But I have been testing it on different and multiple application. On average I got around 400 to 500% improvement in the performance. So yeah, this is a simple demo app, and let's go ahead and test a real app as well. So here is one of the app that I'm using for my testing and for my channel. So this is how I manage my channel. So this is kind of a very heavy application. So these numbers are coming from actually file system. So there is a folder where I put all my videos, and it reads all the videos and reads the whole directory recursively, and then it shows the stats like this. And then this is also coming from SQLite, which is again a file system database. So let's go ahead and now benchmark this guy. So let me quickly stop this, and we will go to channel. Okay, so let me start Octane server here. So this is just to give you a sense that it doesn't, you don't need to just benchmark in a simple demo application. You can actually test it like you on your own, on your production grade application, and see like how much improvement performance you get, and then you can decide, okay, you want to go with Octane or not. Okay, let me run it. Okay, and so yeah, let's go ahead and benchmark this guy now. Let me open it in a new tab, copy this guy. Okay, so we'll be using the worker again, and same settings, keeping 100 connection alive, and we'll be using 4 threads. Okay, so you can see like we are getting 20 requests per second with Nginx. I told you like it's a very heavy application. It's reading the files recursively, and then this is also synced to the cloud. So yeah, there are a lot of things involved here. So, but now let's go ahead and do the same test with the Swoole and with Laravel Octane, and let's see them in change in the performance. So here we'll just change the URL to our Octane URL. And now you can see like the performance increase. We are getting 570 requests per second, which is at least around 2500% increase in the performance. And yeah, so you can see like how much performance improvement you can get with Laravel Octane. And now you can test with your own application by installing Laravel Octane, and then you can decide, okay, you want to go with Laravel Octane or not. Now the next question is a question you might be asking: how the heck Laravel Octane does it? So just to give you the grasp of this concept, let's actually first examine how a traditional Nginx request works. So this is the simple diagram that I made. I just want to show you. So whenever there is a client request comes into the Nginx server, Nginx is a proxy server. So this proxy the request to PHP-fpm via Unix sockets. So if you read the Nginx configuration, you will actually find the Unix sockets there. So this PHP-fpm thread is invoked, a process is invoked. So what PHP-fpm does is it actually finds your application on the hard drive, and then actually loads the application into the memory in the form of executable instructions. Then these instructions are loaded into CPU one by one, and your application executed. The response is generated, and then the response is sent back to the Nginx server, and from the Nginx goes back to the client. And so as you can see, like this happens with every request. So for every request, your PHP-fpm go on to the hard drive, it actually finds your application and it loads your application into the memory. So by loading applications, you have to understand this concept that it, like whenever you are including a namespace, or whenever your composer autoloaded file is generated, so it loads all the file into the memory. Some on demand, some are dynamic loading, some are loading like loaded at bootstrap. So you have to understand like this is all the heavy lifting that is done for every request. So now what happens in case of Laravel Octane? So when we run PHP artisan octane start, so a daemon process is started. So it loads your application into the memory, it bootstrap your application and start an HTTP server. So at this point, your application instruction already loaded into memory, and it's waiting for a request to be executed. So you don't have worry about this whole file system loading. So now with Laravel Octane, this whole flow becomes something like this. So your request comes in, and then your request is mapped to a Laravel Octane process. Your Laravel Octane process have already know like where your application is stored in the memory, and so it start executing this app, and it creates a response and send back to the client. So now you can see all the heavy lifting in the process is removed, and your application is super fast, and you have already seen the performance improvement with Octane. I just also want to highlight that the file heavy lifting is not the only thing that Octane does. So it also utilizes the complete power of the CPU by using programmatic thread. These programmatic threads are called coroutines, and thus providing us concurrency, high level of concurrency. Now you can like you get 570 requests per second, which is pretty awesome. So moving forward, so we know like Laravel Octane is using Swoole and Roadrunner as a high power application server. So let us see like what are these things. So Swoole and Roadrunner, both amazing tools. They provide concurrency and sets a framework to intelligently run application in memory, thus increasing speed and efficiency of PHP. Both uses coroutines, and for Roadrunner is written in Go, and Swoole is written in C++. And so Swoole is using coroutines, and it's called coroutines, but in Roadrunner it's using Go, it calls coroutine. But both are essentially the same concept. So it's a programmatic thread. By making it programmatic, you get a bit some more features, some more control over these thread instead of just process like Unix thread or Unix thread. You get a more control over these thread. Now you can pause these thread, you can resume these thread, and you can actually branch out these thread. So this is how these guys done. I will go into the more detail maybe in my other videos into the low level detail, but on the high level, this is how it does it. And let's take a quick look on how these guys works. So yeah, this is a simple diagram to explain what is Swoole, how Swoole works actually. Whenever there is a request, a coroutine actually picks up this request and start executing this business logic. By business logic mean like executing your like bootstrapping your application and executing the middleware and then validating your request. So this is business logic for you, and taking these variables from data from the request and assigning it to a model. And then this file IO is when you actually call eloquent save method. I'm saying it's a file IO because database is essentially a file system, a storage system, and then a database engine. So file IO mean like file IO is considered a blocking IO. It's considered blocking IO because then CPU has to wait. CPU wait for this file IO to acquire the lock and then to bring this application, bring this data or application to the memory and then do its operation and then release it. So yeah, so whenever so this is a traditional request. Whenever there is a request, it executes the business logic. When there's a file out, it waits with the file out to get a hold of it, and once it gets the hold of it, start executing the rest of the logic. And this is how a request is done. But in case of Swoole or Roadrunner both, actually it has some coroutines. So when coroutines see like there's a blocking IO, so coroutine scheduler actually pause this guy, and then this file IO is delegated to another task worker. So now this task worker is free, and then it can do something else, and in the same time it actually can execute other requests as well. So whenever there's a blocking IO, this is delegated to another task worker, and coroutine can do something else, execute the business logic for in that particular time. And this is how it actually uses the full power of the CPU by actually and provide the concurrency because it does not wait. So it is kind of a non-blocking IO, just like we used to have in Node.js. And now let's go ahead and let's set up Laravel Octane with Swoole and Roadrunner. So here I will show you how you can actually set up Octane and Roadrunner for your new application. So well, we can go to let's actually stop this guy. Okay, we can open a new thread, new tab. Okay, so Octane app new. First of all, Swoole comes as a PECL module. To install in Swoole, you can run PECL install Swoole. So it will actually download this Swoole binary, Swoole source code, and then it will try to compile it with your current version of PHP. And if you don't know how to get the PECL, you can actually go to PHP peer. Yeah, so yeah, this is the PHP peer extension. So you can install this PHP peer. I will add the download and all the instruction in the YouTube description. Don't worry about it for now. So yeah, so you can install PECL, and then from the PECL you can install Swoole. So once you have Swoole installed, you can actually run your application in Swoole. And to install the Roadrunner, we can go to the Roadrunner, and Roadrunner comes as a PHP package. So we can go ahead and install Roadrunner. Okay, so once you get the Roadrunner, you also need to get the Roadrunner binary, so which we can download by running this command. So this is the binary that is written in Go, so it is downloading. No, we don't need YAML. So yeah, now we have our Swoole and Roadrunner both installed. Let's actually try to run with Swoole first, and let's see like how much request per second that we get. This is a very fresh Laravel application. So let's check the performance with this, with benchmark this with between Swoole and Roadrunner, and then we will do the same for the real app. So you get the sense of like you get the difference between what is the real app and how much it can improve the performance of a static application, and how much it can improve the performance of an application that is using a very high file IO. Okay, so now we're running it on Swoole, and let's go ahead and benchmark this guy. Okay, you can see like we are getting all the requests, and it is serving all the requests, and it's showing like how much response time it needs. Okay, so we're getting 485 requests per second with Swoole, and let's actually run this up with the Roadrunner now. It might give an error because the binary might not be executable. Let's make it executable and let's run it again. Okay, so now this is running on Roadrunner. Let's do the same test again. Okay, it is serving now 468 requests per second. So this is a demo app, and you can see like the performance is pretty much equal. So I have been testing it like on actually multiple application. So far I have found Swoole a bit better with than the Roadrunner, but it's up to you. You can actually benchmark your own application, and then you can decide on which server your application runs better, and so then you can use that. Let me go ahead and stop it. So, and now like we will do a benchmarking on a real application with Swoole and Roadrunner. So I have Swoole and Roadrunner both installed in my channel app. So it is again the same app that I showed you before. So let's do a benchmarking on this with Swoole and Roadrunner. So let me start with, and let's actually open a new tab. I am just keep opening the new tab because I want to put these results on the slide as well. Okay, so we got our server running. So we'll be using worker again. So it's running 466 requests per second with a real application now. And let's go ahead and now run it with Roadrunner and see like how much change in performance we'll get. Okay, with Swoole we are getting like 466 requests per second, but with Roadrunner we are getting 92 requests per second. This actually keeps changing. Let me run it again, and just to make sure that we didn't change anything. Okay, so the server is also servers are actually stopped. So let's go ahead and start it again. So server was actually stopped again, and actually let me publish the octane config, and we are using Roadrunner, and let's run this again. Okay, so we keep getting errors with Roadrunner, but I have been testing like their performance is pretty much equal, but I think there must be a problem with the application that I am testing. So it could be the problem. So yeah, but you got the idea that between the performance of Swoole and Roadrunner. So far I have actually deployed two production grade application onto my own Ubuntu server. So I have been getting a very good results from both Swoole and Roadrunner, but you can actually test your own application, benchmark it, and then you can decide, okay, which server you need to use. Okay, and so I will be putting the demo results for both of these on the slide, and I will put the link of this presentation as well in the description, so you can actually use it if you want to. Now the next topic is Laravel Octane internals. So what I mean by Laravel Octane internal, let's go ahead and check it out. So to understand like what Laravel Octane actually brings for us is, so the thing is, whenever if we run PHP Artisan Octane start, we have discussed it. The application is bootstrap and put it into memory, and it exposes an HTTP server, so which is ready to serve our request. So what does it actually mean is, so our application is bootstrap. So what it means is our containers is now shared. So we have one container for our application. So now which is shared between every request. So Laravel Octane actually does this for us. It gives the separate container or a new container instance for every request. It's not actually initialize, but it actually creates a copy and give the new copy to every request. And since the whole application is in the memory, so it doesn't have to do a lot of work, but it just actually executes the instruction in the memory, and which is like very fast. And what again, like by container sharing the container, it also means that all the bindings are shared, like all the container bindings are shared, for example configuration, authentication, and view builder. So you make any change into the configuration, authentication, view, and other binding, so this change would be reflected in other places as well. So this is where actually Laravel Octane comes into play, and it does all these cleanup for us. Let me actually quickly show you where it does is. So we can actually find config. Okay. So this is the config Octane. So these are the listeners actually that Laravel uses. Laravel is using event listener pattern to actually for the cleanup. So whenever there is a new request received, it actually runs these two guys. Actually, I wanted to show you this one first. So you can see like for every new request, it flush all the local state, like any local state that you have created during the last request. It flushed all the queued cookies. For example, in your last request, you attached some cookies and there were cookies in it. So you don't want this to be replicated in another request. So these are flushed. Session state is flushed. Authentication state is flushed. It enforces the request scheme, and then it ensures port magic scheme, and you can read all about it. And then at the end, it actually gives new request instance to the application. So the difference between request received and prepare for next operation and request is like whenever there is a new request, it this is the new request for this Swoole server or a Roadrunner, and operation is whenever there is a task completed, and then whenever there is a task in the queue or task is received or executed, this is called an operation in Laravel Octane. Okay, and yeah, that's all the thing that I want to talk about. One more thing. So yeah, this is where actually it starts your Swoole server. So you can actually find it on the Octane. This is a CLI command. So as you can see, like it starts a new process. It tells it, okay, you need to start the Swoole server, and this is a binary path. So if we go here to Laravel, octane and binary, and we can see like we get a Swoole server binary here. So this is essentially Swoole server that is running all the code for that, and then actually it gives it the base path of this, and yeah, and that's all the thing that you need to do, and then it actually start the server. So yeah, that's all I wanted to show you for Laravel internal for now, and I will make another video, a low level video on that, hopefully maybe in few days. Okay, now I just want to talk about Laravel Octane CLI. Although I have created another video on Laravel Octane CLI, you might get a suggestion on your right side. But in this video, I just want to show you one thing, because I was thinking like maybe in this video I will compose a lot of stuff so that you can, with just one video, you can get started and started learning this Laravel Octane. Okay, so in the Roadrunner, I just wanted to show you one thing. Let me actually start this server. So now we're running it on Swoole, and what I want to show you is, so since our application is in memory, so if you make any change in the code, for example, I just want to change this guy, this label, welcome back. Okay, let's go ahead and check it, find it. So it's a home controller index page and index. Okay, so this is the author name. Okay, welcome back, Rehan Manzoor. So here instead of dot, maybe how are you? Let's put this. How are you today? And let's refresh it. Actually, I think this let's clear out the view thing so we get the refreshed view. But let's go ahead and test another. Maybe we can remove these guys, and we can put route.get octane test. I want to show you this because the application is memory, so it's hard for the Octane to actually refresh it. If you refresh to look for the changes in the file, because all the application memory, so it need to reload the application. Let's go ahead and return. Okay, let's check the Octane test route now. Okay, so we are using Octane. So we see like it is not able to detect the change because your application is already in memory, so there is no way it can know like if there is a change in the code or not. So when you are developing in the application with Octane, so you can use this flag that is called hot, I guess. So actually I think it's something else. Let's quickly check it. Okay, yeah, it's watch. So let's actually run it with watch. So what watch does is it actually keep an eye on your application and see like if there's any change in the file, it executes the change. Let's change it to hello world now, and let's see if it works. Okay, so now you can see like it works. Let's change it again and see like if it is able to hello world again. Let's refresh this application. Okay, so now you can see it's able to reload the chain. So let's actually check it in the CLI as well. So now you can see like whenever there is an application change detected, it restart all the worker. so workers are able to see the chain, and it is using Chokidar to detect the changes. So you can see, like, here is the file watcher that it is using for to detect the changes. And if you want to actually customize the behavior of this, that these are the only folders that you want this to see or detect the change, so this is where you can do it. You can change it. If you run PHP artisan octane install, it will publish this configuration in your config folder, and here in the watch folder you can actually customize the folders. You can change the app, bootstrap, so these are the folders, and then you can add your own files if you want to. So yeah, that's all I wanted to show you. Yeah, so as a bonus, I just wanted to show you, I already made this video, but the voice was not pretty clear, so I thought I will make another, put a small segment of this. So let's go ahead and do some benchmarking with Swoole without Octane. And I actually created this already, a server here. So this is a simple hello world program with Node, and this is a simple hello world program with Nginx that will be running, and this is a simple Swoole server. So because we know, like, we always keep listening that, okay, Node is so much better because it is so concurrent and it is able to serve so many requests per second. So let's see how much difference we get with Swoole, Node, and PHP. Okay, so let me actually open this in the browser first. Let's see if we have everything. Let me get the Swoole experiment. So okay, so this is the Swoole experiment. Let's first actually start with Node. So I'll be going here, and we can go Swoole experiment. Okay, and let's go to Node, and we can run with Node main.js. Okay, so now the application is running on the HTTP and this port. So let's actually run benchmark using worker again. So you can see, like, with with Node.js, it is able to serve 33,630 requests per second, which is extremely amazing. And now let's actually close this server, and so this part is running on Nginx. So let's now benchmark Nginx. Let's see how much we get requests per second with Nginx. It's a simple hello world application. There is nothing fancy about it. So with the Nginx, we only get 1100 requests per second, 1120 requests per second. So you can see how much is the difference between simple Node and simple Nginx application, PHP-fpm application. Now let's actually run this with the Swoole server. Let's say PHP, and this is the file. Okay. So the Swoole server is now running at this point. Let's go ahead and run the benchmark with this. Now you can see the difference: 83,688 requests per second, and Node is 33,630 requests per second, and with Nginx PHP it's only 1120 requests per second. So you can see the difference, like, Swoole brings to the table. And you know, like, I just wanted to point out the fact that Swoole was created by Chinese developers in, like, in later 2012, and they have been using it since then. And it was recently, like, quite recently adopted by the PHP community, because we know, like, now the Laravel is leading this whole PHP front at a PHP framework front. So in March 2021, Taylor Otwell actually gave a talk about Swoole, and since then it created a buzz in the PHP world, and now everybody is going towards Swoole, and it is pretty amazing. Chinese have been using it since very long, and it has been tested in the market. So yeah, you can actually use it in your application and have fun. So yeah, that's all from my side. At the end, I just want to say you are awesome, because you are watching this channel, you are learning, and you are trying to be better. And PHP is awesome. People were saying PHP will be dead, but PHP is getting more and more amazing, and Laravel makes it so much cooler. So yeah, I would just want to end this session here. And yeah, if you like this video, give me a thumbs up, like, share, and share with your friends, and don't forget to subscribe to this channel. So yeah, I'll see you in the next video. Till then, bye bye.